Okay, the radical side here, it will turns into the hydrogen, okay, and the radical, the active side here will become a double bond here. So we will left a single bond and double bond. Okay, for this structure, you just copy down the above structure, but with the presence of double bond. So KTD is the rate constant of termination during disproportionation process. Now we look at the termination by chain transfer. Termination can also occur by transfer of the active center to another molecule AB, which may be monomer, initiator, solvent, polymer, retarders, inhibitors, and reinitiating a new chain. Okay, this is called as the termination by chain transfer. Now we look at the termination by chain transfer. First, by the okay, we look at the overall process of chain transfer first. Chain transfer occurs when a chain stops growing, but the polymerization does not stop because a new radical is generated. So it happened by the hydrogen abstraction from the initiator, monomer, polymer, or solvent. Let's say if you have a monomer here together with the initiator, which is in the propagation step. So you want to terminate by chain transfer. Okay, you want to stop growing the propagation of the polymer. Okay, but you don't want to you want to stop the chain grow, but you don't want to stop the polymerization process, right? So you need to use the chain transfer. So it will produce propagation polymer together with the hydrogen abstraction. Okay, or SH, we call it SH here is the solvent or any other molecule with an abstractable hydrogen atom. Now we look at the product of the termination by chain transfer. Okay, this is the product from the propagation step of the polystyrene with benzoyl peroxide, and SH is the solvent. Okay, solvent or any other molecule. So we use solvent that have a hydrogen abstractable. Okay, abstractable. So the structure, we just copy down the structure above, and with the presence of hydrogen. Okay, because the active side here is left side, and we convert it to to another hydrogen. Okay, to another hydrogen. So leave it as CH2 and S together with hydrogen abstractable. Okay. Chain transfer agent can then add monomer units to continue polymerization process. Okay, this is another example of chain termination by chain transfer. Another one is a chain transfer to monomer. Okay, chain transfer to monomer is a transfer of the hydrogen. The transfer of a hydrogen can occur either from the monomer to a propagating microradical or in the reverse direction. Okay, in other case, the active site is transferred to the monomer and the growth of the polymer radical is terminated. From a transfer of hydrogen can occur either from monomer to propagation. You can see that the hydrogen abstraction occur in this structure. And hydrogen donation refer to the active site here is transferred to the monomer and the growth of the polymer radical is terminated. Now we look at the chain transfer to the initiator. Okay, one chain is terminated but another one initiates. This particular reaction reduces molecular weight and weighs in. The chain transferred from initiator produce a dead polymer, and it also produce another chain which is reinitiates. Chain transfer to solvent. A significant decrease in polymer chain length is found when polymerization is carried out in solution rather than in undiluted state. Transfer to solvent effectiveness depends on solvent amount, strength of the breaking bond, and the stability of the solvent radical form. For example, is the structure of the polystyrene together with the radical sites reacted to the solvent of chloroform to produce styrene. Polystyrene together with the chlorine are attached to it, and CCl3 with the radical form. Now we look at the chain transfer to polymer molecule. If the chain and radical attack an atom on the backbone of the same or another chain, the result is a new radical that can reinitiate to form a branch. So chain transfer to polymer, for example, backbiting reaction in polymerization of polyethylene. So it will produce a short chain branching. And the chemistry is driven by the greater stability of the secondary radical that form compared to the primary one at the chain end. And the most convenient site of attack is a hydrogen atom that is a short distance back on the same chain. So short branches are very common. So chain transfer to polymer is backbiting process of polyethylene. Alright. Now we look at the chain transfer to the retarders. Okay. In many cases, a chain transfer agent is added purposely to the reaction mixture to regulate molecular weight. Many compounds work well for this purpose, but mercaptans, also known as thiols, are the most general. Example is the use for polystyrene and butyl mercaptan. Okay, this one is the structure of polystyrene and this one is the butyl mercaptan. The sulfur-centered radical reinitiate very efficiently. The result is a decrease of the molecular weight without changing the overall rate of conversion of monomer to polymer. And we use more initiator is another way to decrease the molecular weight. But the reaction rate will increase proportionally a possible dangerous situation. Alright. In this structure, it shows the chain transfer to inhibitors. Okay. In this termination reaction, the chain transfer occurs, but the new radical is incapable of reinitiate. Okay, compared to the chain transfer to retarders. The most common inhibitors used are phenol with bulky group auto to the OH group. This one is the different or comparison between the combination and disproportionation, which is step in the termination. Okay, for coupling or combination, it will tend to produce one polymer chain with single head-to-head linkage. A polymer chain contains two initiator fragments, which is R per molecule, and termination by coupling will produce higher average molecular weight. For termination by disproportionation, it will produce two polymer chain. One polymer chain contains double bond and the second one only single bond. And each polymer chain contains one initiator. And it will produce lower average molecular weight. This one is the example of initiator. AIBN monomer is we use vinyl monomer. Okay, this one is the structure of AIBN. Now we look at the decomposition step process. The breakup of the bond is happen between N, okay, between the structure N. So we will produce CH2CC, okay. It will produce 2 CH3, CCN, CH3 together with the N, okay, and nitrogen. And this structure, you left the N structure, nitrogen structure, you just take out or copy the structure with the radical only, okay, will be reacted with vinyl monomer. So We have CH2, CH, so R is the alkyl side. And I just copy down the structure of the dissociation or decomposition process. Okay, and then combine with the structure of the monomer without double bond. Okay, it will left a single bond together with the active site. Don't forget to put the active center, active site or radical site. And then you just copy the structure during the association process, and then we will react with another monomer. Okay, so it should be double bond here, and it will be produce a polymer during the propagation to produce propagation polymer with together with the active site terminated with the n number of polymer propagate. And during the termination by combination, we can see that the propagation process it will meet with another propagating species. Make sure it will mix both active site here to produce um, termination or polymer during termination which have the structure of the AIBN at the end of the end group here. Okay, the structure here. And during the termination by disproportionation, it will left to produce polymer with double bond, and the second one is single bond. Make sure the hydrogen here come, okay, the hydrogen, not hydrogen, the double bond here come from the structure here, which is the active site here will be transferred into the double bond right here. And the active site here will be transfer or become the hydrogen atom that attached to the carbon here. Okay, this one is the initiation that use peroxide. Okay, hydrogen peroxide and styrene that I have shown you in the previous slide. Okay, and this one is the overall reaction that I've shown you earlier during the first step of polystyrene react with benzoyl peroxide. And if you want to practice draw it, you can start to draw with another monomer. Okay, for example PP, or you want to use the PMMA, okay, monomer monomer MMA, or monomer ethylene, vinyl chloride, and so on. Try to react with initiator, okay, BPO, AIBN, and so on. Okay, commonly used we use AIBN or BPO because the structure is easy to draw. Okay, now we look at the tromsdorff effect, which is also called as a gel effect, Norris-Smith effect. Okay, gel effect occur in bulk or concentrated solution polymerization. So gel effect happen when chain mobility of the polymer is reduced during the polymerization process. The rate of termination also reduced, but the monomer concentration together with the radical is increased, and the polymerization process is increased. It will release of more heat, the rate of initiation increase, and we produce the rate of polymerization also increase. So when the heat increase and the chain mobility is decreased, it will lead to produce the auto acceleration or the explosion of the process. So auto acceleration may result in the rapid increase in polymer concentration and also lead to increase in polymer viscosity. It will lead to reduce to growing the entangling power. Termination is further suppressed. Chain become even longer. The conversion rate rise still further. So there are some ways to minimize the tromsdorff effect in free radical reaction. We can add solvent to facilitate heat transfer and reduce the viscosity. And we can add polymerization by batch to batch. We can do the polymerization which is batch by batch, which is we control the amount of the monomer. And we can also add inhibitor or retarder. Okay. That's all.